This tutorial will be discussing aldehydes and ketones. Aldehydes and ketones have one thing in common, a carbonyl group. That's a carbon-oxygen double bond. Now the location of that double bonded oxygen is what differentiates an aldehyde from a ketone, but they both have those in there. So oxygen is an extremely electronegative element. So the electrons tend to drift towards the oxygen, so we do have an area of electronegativity here that will help it with reactions. Now the difference between the aldehyde and ketone is where that carbonyl group is located. You'll notice on the aldehyde that double bonded oxygen is always on the end, whereas in a ketone it's always in the middle somewhere. In fact, the aldehyde is actually considered a terminal double bonded oxygen, meaning you will only find it at the end. So as you're looking over different compounds, you're trying to decide which one it is, look to see if the double bonded oxygen is at the end or if it's in the middle. Just as shorthand, just so you don't get confused when you see it in the future, CHO is shorthand for this, for that double bonded oxygen. Whereas the CO here is shorthanded for the ketone. Alright, so naming these aldehydes. It's very similar to the same pattern we've seen where you take the base, meth, eth, prop, whatever, and take off that last E if it was an alkane name and exchange it with Al. It's very easy to confuse alcohols, which end in OL, with aldehydes, which end in AL. So be very careful as you're writing it and as you're reading the question. If we're looking at common names, the first four aldehydes actually have common names, and that has to do with those prefixes right here. Straight memorization: 1 is form, 2 is acete, 3 is propion, and 4 is butyl. And they just end it with the word aldehyde. So just to give you some kind of reference, this is a methane group with that double bonded oxygen, right? So ordinarily this would be methane. We take off that E and we slap on an Al, so it's methanal. The common name is formaldehyde. There's 2 carbons here, so that would be ethane. And we're going to take off that last E and add that Al for ethanol. Propane becomes propanol. Butane becomes butanol. And here's our common names. Once again, the common names are merely memorization. One thing I want you to also notice that every single time that oxygen is at the very, very end. So let's name something. Here we always start with the double bonded oxygen and go to the direction away from it. This is at the end. The double bonded oxygen is at the end. That's how I know it's an aldehyde. Even if it didn't say the word aldehyde, I would know it's an aldehyde because it's at the end. 1, 2, 3, 4, 5. 5 is pent. If I was doing it as an alkane, it would be pentane. But I'm going to take away that E and write Al because it's an aldehyde. I'm still have a methyl group there, so 2-methyl pentanol. Ketones, instead of taking away the E and adding the Al, you're going to take away the E and add ONE. And it's pronounced own. It's a long O. Ketone. So here we have 3. Propane becomes propanone. Butane becomes butanone. Once you get to 5, you have to start telling people where that double bonded oxygen is. You never had to tell people where that double bonded oxygen is with aldehydes, because no matter what, it's always going to be at the end. Whereas here, it's not necessarily at the end, it's in the middle somewhere. So you have to tell people where it is once you get past 4. So pentane becomes pentanone, and it's on the 3rd carbon. This is a cyclohexane with a ketone in it. So cyclohexanone, because that's where the ketone is, we start counting at that double bonded oxygen. 1, 2, 3. On the 3rd carbon is a methyl group. So let's name this one. 1, 2, 3, 4, 5. Notice I started counting on the side with the double bonded oxygen. So I know it's pent because there's 5. Instead of pentane, it's pentanone. I have to tell people where that double bonded oxygen is, so I'm going to throw the number 2 in there. So 2-pentanone. I have a carbon here that's unaccounted for, so I have to say 4-methyl. 4-methylpentanone, 2-pentanone. Alright, so let's talk about solubility. Here we have, once again, the hydrogen bonding, which isn't real bonding, it's an attraction. So we have the oxygen, which is partially negative, being attracted to the hydrogen that's partially positive of the water. But remember when we were talking about aldehyde or alcohols, it can only work if there's a small amount of carbons. So if we look here, methanol is soluble, ethanol is soluble. Notice there's not even an option for ketones in there because there's not enough carbons to have it be in the center. Either way, that oxygen is going to be at the end. Once we get to 3, we have the option of putting the oxygen in the middle. Once again, 3 is soluble. I said that 4 was the magic number because you're going to see 4 come up over and over and over again. When we were at alcohols, 4 was slightly soluble, and then 5 is insoluble. Here, 4 is soluble, where 5 is slightly soluble, and then 6 is not soluble at all. Alright, so which one's an aldehyde and which one's a ketone? Remember, if it's at the end, it's a aldehyde. If it's in the middle, it's a ketone. So here, it's in the middle because it's surrounded by carbons. So that's going to be a ketone. Here, it's at the very end. It's a terminal one. So that's an aldehyde. Here, it's at the end. It's an aldehyde. And this one here is in the middle, so it's a ketone. Let's name this ketone now. Start in the direction of the oxygen being on the furthest, being the closest to the number 1. 1, 2, 3, 4, 5, 6. It's on the 2nd carbon. It's 6, so it's hexane. So that becomes hexanone. And it's on the 2nd carbon. Alright, one last one. Start on the side closest to the oxygen. 1, 2, 3, 4. That's a Cl. That's not a C. That's not a carbon. That's a chlorine. So we have 4, which is bute. So instead of butane, it's butanone. I know it's a ketone because it's in the middle. It's not in the end. It's on the 2nd carbon. And on the 4th carbon, there's a chloro. And that's the difference between aldehydes and ketones.